So for the Nyquist graph, I copy all the data and then I go to the recommend chart and I click the XY scatter. So I got this graph. I rename the graph name into the Nyquist plot and I insert the XY title. For the Y title is the imaginary and the X title is Z real. So after that I interpolate the graph. So for the inhibitor line I use 9, I use 12, and for the coating line is 9, and lastly is 3. So next the second graph is tafel plot. So for this graph I insert data one by one, X and Y axis. So first I click for the 10 minute and I insert the Y and X data, and then I insert the Y data. So it's for the 10 minute and smart also the same. So that I got this graph. So I rename this graph into the tafel plot. So for the y-axis I rename into the log icord and ma, and then for the x-axis I rename into v electrode potential vse ecore. So after that I interpolate the graph using the line. So you can look at this.
So for the Nyquist plot, we can, after extrapolate our graph, we can find polarization resistance for inhibitors, control sample, and coating. So for the RP value of inhibitors is 5.3 ohm, for control sample is 2.8 ohm, and coating is 5.4 ohm. So looking at the RP value, we know that which are efficient. So to compare which are efficient, we can look for the highest RP value and largest semicircle. So we know that its coating is more efficient because it has highest value, which is 5.4, and largest semicircle. So to construct the equivalent circuit, we can look for the graph shape. which is all of that has a semicircle shape. So because of semicircle shape, it only has one common shape of circle, which is this drawing show that the circuit has two resistance and one capacitor. This is called RRC circuit. So for the TEFL plot, we can look for the graph, and we got we can find ICO and ECO value. So for the 10-minute, ICO value is negative 6.9 and ECO value is 0.04. And for the 10-minute, ICO value is negative 6.1 and ECO value is negative 0.08. And lastly is MAT. ICO value is negative 6.3 and ECO value is negative 0.07. So to compare which are more efficient, we can look for the ICO value. If the ICO value is low, it has a high corrosion resistance. And if more positive ECO, it has a less corrosion thermodynamical tendency. So looking for the table, we know that 0-minute is the best corrosion resistant because it has the lowest ICO value. And so for the smart and 10-minute, smart is more efficient because it has low value than 10-minute.